Hello geometry students, here we're in lesson 10-2 and we will start off with some new vocabulary, and that new vocabulary, central angle, which is not really new vocabulary, we've had that before. We have arc, we have minor arc and major arc, we have semicircle, congruent arcs, adjacent arcs, and then finally arc length. So we have a key concept here. It's called the sum of central angles, and that should equal 360 degrees. Also in a semicircle, which is basically, let's turn our pen on here. And we're going to go back a slide. I was trying to draw something. So in a semicircle, which is half of the circle, it's only 180 degrees. So here we're trying to find the value of x. So what we can do is we can add up RTS. We can add that to the 13x minus 3, which is the STU, and then add that to the 5x plus 5, and that represents the 180 degrees. So, sum of the measures of the three angles is 180. Add them all up, combine like terms, add 2, and then divide by 26. So we end up with x equals 7. So, here's a problem for you to try. Go ahead and pause your video and solve for x. If you got that the value of x equals 9, let's see how that would work. That would be that 75 degrees plus our 5x minus 5 plus our 7x plus 2, and the sum of all those should be 180. So we're going to add up our 75, subtract 5, that would be 70, and add 2, that'd be 72. So we have 72. And then we're going to add our x's, and that will give us 12x. And then this should equal 180. Then we have 12x. We're going to subtract 72 from both sides, and that would give me 108. And then divide both sides by 12, and that will give me 9. So there's x equals 9. Okay, here's another key concept. It's called a minor arc. A minor arc is the shortest arc connecting two endpoints on a circle. Okay, the measure of a minor arc is always going to be less than 180. It's going to be equal to the measure of its related central angle. So it's called a minor arc. Okay, then you have a major arc, and it's always going to be over 180. Okay, so greater than 180. Okay, is our major arc. And again, the semicircle, which we discussed a little bit earlier, is 180 degrees. Progress. Okay, you're going to identify arc LO. Is it major, minor, or semicircle? Go ahead and pause your video. Good, if you said minor arc, that's good. It actually is 90 degrees. It's under 180. It's a minor arc. Okay. Check your progress on this one too. MLO, arc MLO. You are correct if you said semicircle. It's 180 degrees. And then finally LNO. So we're starting at L. Starting here at L, going around. It's a major arc. You are correct, major arc. Okay, now we have a theorem. Theorem 10.1 says, in the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent. Alright, so that seems pretty straightforward. We have angle 1 and angle 2 are being congruent, therefore arc FG must be congruent to arc GH. pick up my pen here. There we go. All right. So here's a real-world example. It says refer to the circle graph, and we're going to find the measurement of KL. Well, the measurement of KL is 21% of the entire circle. Okay, 21% of the entire circle of 360 degrees. Okay, so 21% of 360 is, we're going to find that. 21% times 360, and that gives me an answer of 75.6 degrees. Now we're also going to find the arc NJL. Okay? Now NJL starts here at N, goes around, includes the 26, the 37, 21, stops there. So NJL is everything except for 16%. So it looks like it's going to be 84% of the entire degree measure of 360 degrees. Or you would do it this way. Seems like a little harder. All right, 302.4. Okay, here's an example for you to try. Go ahead and pause your video and try to find the measurement of arc BC. Okay, we said 140.4. That's right, because that is 39% of 360. Okay. Now you're going to refer to the circle graph, and you're going to find the measurement of arc ACB. Go ahead and pause your video. ACB. So not A to B, not the 24% of the squirrels, but everything but that, ACB. Okay. Go ahead and pause your video. If you said 273.6, that's correct. That's basically 76%, right, times 360. Okay, new postulate. Arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So this is not new. This is something that we repeated from early on in Mathia. So arc XYZ is found by adding arc XY to the measurement of arc YZ. Okay, so we're going to find the measurement of arc LHI. Oh, go all the way around like this. Right? Well, we know that arc of IJ, right? Sorry, arc IJ is 90 degrees because its center angle is 90 degrees. So we know this is 90 degrees, and this forms a semicircle, so this has to be 90 degrees. And we already have 32 of it. Okay? So if we're finding LHI, it doesn't matter that we know it's 32. We know that LHI must also be 90. And angle LH would be 58. So measurement of LH is 58, but the measurement of LHI would be 90. Here we go. Okay, use the arc addition to find measures of arcs. Okay, we have try to find in the next one the measurement of arc IJK. So, how are we going to find I, J, and all the way around to K? Think about that for a second. Now, I think we already know. Remember, we found that this arc was 58 degrees. I believe this is a vertical angle. And, whoops, we're going to add our 90 to our 58. There we go. 90 plus 58 is our 148. Okay, check your progress. You're going to find the measurement of arc EAB. EAB. You said 90 degrees, you are 52 degrees. EAB. EAB would be 90. I think they meant to say their measurement of arc EA would be 52. So the answer should be C, 90, for the question that was asked. Okay, find the arc BCD. Okay, you said 142, you did it right. Okay. Arc length. So this relates definitely to the mathia. So we have the ratio of the length of an arc to the circumference. So if you take the angle X in the middle here, and you divide that by 360, and you multiply it by 2 pi r, then you actually get the length here, up here. Okay, see an example here. We're trying to find the length of DA, and we know that the radius is 4.5. So we're going to take 40, and we're going to divide that by 360, and then we're going to multiply that by 2 pi r. And my R is 4.5. So there's our setup. So the measurement ends up being about 3.14. Okay, so we're going to find the length of DA. DA. Now, that's a semicircle from A to C. Therefore, DA does have a measure of 62 degrees. So we're going to use 62 out of my 360. As my proportion of the entire circle. And then that's going to be multiplied by our 2 pi r. And it looks like my r is 6 centimeters. So there's my setup. So we have x over 360 times 2 pi r. We decided, though, it was going to be a 180 minus 28. Oh, which I guess I can't subtract, should be 162. That was my bad. That's not even true. Wow. This number here is definitely not 62 or even 162. It's going to be 180 minus my 28. And that ends up being 152. Alright, here we're going to find the length of DA. Okay, and it looks like 140 degrees was given to us. So we have 140 out of 360. That's the part of the circle. And I'm going to multiply it by 2 pi r. And it looks like my radius is 6. Answer then ends up being 14.67.